This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Brian Brazil is the founder of Robust Perception, a company that helps scale and support users of the open source Prometheus monitoring tool. Brian has committed heavily to the Prometheus project. Before starting Robust Perception, Brian worked at Google. Brian, welcome to Software Engineering Radio.
Hi, Jeff. Glad to be here.
Let's start off by just talking about monitoring. What is monitoring?
So I've talked to lots of people over the last year or so, and different people have very, very different ideas of what monitoring is. For example, I've had people, when I say to them, I do monitoring, thinking that I'm, watching their network traffic to see if they're accessing Facebook and work, which is obviously not what we do. So I see monitoring as kind of four things. One is alerting you when there is a problem or there's about to be a problem, a business level problem. The second thing is giving the information you need to be able to debug that problem. And then the third thing is to do long-term trending and making business decisions. Like if you know your cache hit rate is 90% and your change will go to 95%, then that means maybe we can get rid of hardware or add new hardware. And the fourth one is just general plumbing. So for example, if a hard drive fails, at the end of the day, you have to send a human in to fix that because the robots aren't good enough yet. So those are kind of the four things I see with monitoring in the computer space.
Awesome. Give me an example of something that you monitored when you worked at Google.
So I was primarily working in ads at Google. So we were monitoring the system, like the number of queries coming in per second, the error rate, the latency, as well as more system details. So like we had tons and tons of stats.
Right, absolutely. And I want to use that as an example later on, but we're talking about Prometheus today, and you've claimed that Prometheus is a next generation monitoring system. Could you talk about how monitoring using Prometheus would differ from a monitoring tool of the previous generation?
Okay, so if you're looking at the previous generation, you're going to look at something like, say, Nagios, or something else that's derived up from it, from which there are quite a few. So Nagios works on the principle of per machine checks. So it's basically, I run this shell script, it returns true or false, and based on that, I send alert to a human. So this is fine when you have, 5 machines that you're carefully caring for, intending, and feeding. But when you're talking like the current generation, when people are talking about serverless, talking about cloud native, you might have hundreds of machines which are tiny and which appear and disappear all the time. So, an alert on a single machine isn't really that useful. And it also might be the case that, one machine is being a little slow. That doesn't necessarily mean the service as a whole is having a problem because you're still well within SLA. So like the canonical example, I think where this comes in is you're running some form of web service and you have an SLA for latency. Let's say latency has to be under a second. But if you are using something like Nagios, it's extremely difficult using just Nagios to alert on the fact that your latency is over a second, because you can only look at each machine and you have to get that data somehow, and you can't look at the overall service view. So what a lot of people end up doing is alerting on CPU being high, which sometimes might indicate a problem, but it's not going to spot a deadlock, for example. And it's also going to have lots of false positives. Let's say if log rotate runs a bit long. Whereas with Prometheus, because you're getting insight from the inside all the applications, you can get that latency, you can aggregate it up correctly and say, hey, I'm currently doing 880 milliseconds, everything's fine. And if one server is a little slow, as long as you're under that second, everything's good. And also because it's meant for dynamic cloud environments, as machines are added or removed by autoscaling or whatnot, Prometheus will automatically pick that up and take care of it. You don't, as with Nagios, have to restart it and update the config every time.
Talk a little bit more about why the move to cloud architecture changes how we are doing monitoring.
Well, the cloud architecture and there's microservices as well to some extent affect it, because previously you'd have a few bare metal machines And because you've only a handful of them, you can get away with doing things, well, by hand. As you move into more dynamic environments and cloud environments, machines aren't really a thing anymore. What you have more is some form of computing substrate. Because you'll say, hey, give me 2 CPUs, a gig of RAM, and a bit of disk, and it lands somewhere. So there's no longer this tight binding between the services and the instances and the processes you're running and the actual machines. So you have to care a lot more about where things are and be able to deal with that, because you're no longer talking about, the MySQL machine. It is a machine which is currently running one part of the MySQL service.
When we're talking about monitoring, does monitoring also encompass the act of responding to events, or is it merely the processing of events and the creation of metrics about those events?
Well, that's one of those things that it depends who you talk to. Because personally, I would say the monitoring ends when it's sitting in something like PagerDuty, and then you're on to incident response. Other people would say it's part of the system. It probably really boils down to your cultural philosophy. So, for example, if you have a knock and that's part of your control system for keeping things running, then arguably that's part of monitoring. Whereas if you're taking the approach where everything's more SLA based and so on, it's going to human, we're putting a lot of intelligent thought behind things, it's kind of a separate incident response thing. But it probably really just matters in your personal opinion. I don't think there's a bright line answer on that one.
Mm-hmm. In the past, software companies would often end up with a variety of monitoring tools. Why did that happen?
So the thing is that there's various tools that have been developed over time that just do one thing particularly well or supported one integration particularly well. Like for example, if you're going to be using, say, Elasticsearch, it has its own thing. If you're using Cassandra, you have Data Access tool, and each of those are integrated and work well for just that tool. And then you end up with all of those over time handling different things. So one of the things that I think is neat about Prometheus is that because we have all these integrations, that's great, but every other monitoring system out there also has to implement those, whether they're commercial or open source. And that's kind of annoying that we're all spending our time re-implementing these integrations rather than focusing on the more interesting problems. So one of the things with Prometheus is that, yes, we have all our exporters, and we also provide the APIs and the interfaces that you can reuse them for other monitoring systems. So that other people, you don't have to duplicate as much stuff.
Right. So is that duplication, would you say that's the main consequence of, the main negative consequence of when a software company has to run multiple monitoring tools?
Yeah, it's one of the duplications. And then each of them tends to have a slightly different philosophy, slightly different data models, different alert thresholds, different levels of power. And as with any system, whether it's a build system or a language or even a text editor, if we're going to start the Vimverse Emacs wars, for every single additional one of those you have in your ecosystem, that's more cognitive load for all your team. So it's not so much that it's monitoring, it's just that's one more thing everyone has to learn and learn all the intricacies of and all the special cases and all that sort of thing. So if you're able to consolidate down so that the size of the system people have to understand is smaller, that's better for everyone.
As we get to talking about Prometheus, Prometheus is based on a monitoring tool that was built inside of Google called Borgmon. What was unique about Borgmon?
So I don't know too much of the history of Borgmon. I just used it a lot. I think Borgmon, because if you look at Prometheus, it's just that it's meant for dynamic environments. It has labels called tags or dimensions, depending on what system you're looking at, and it has a powerful query language. And then it can just take all that data, so it can ingest large amounts of data, process it, and produce pretty high quality data and information out of that. I think that's kind of really unique, is that you have the labels and you have the query language.
Borgmon was is the monitoring system that monitors Google's Borg. What is Prometheus? Why did Prometheus get created?
So Prometheus was started off in SoundCloud by Julius and Matt because, by my understanding, they had StatsD and it wasn't scaling particularly well for them. So they started, doing a spike to develop a better system. And that's where Prometheus started. And then I got involved like a year and a half later. And here we are now, 3.5 years in? So kind of just started off as a reaction to the existing monitoring systems not being good enough.
Right. So Prometheus improves the visibility into the internal health of our services. What is Prometheus doing in contrast to other monitoring tools?
Well, do you have a specific tool in mind? Because there's 3 or 4 broad categories.
No, I didn't have anything in mind. What would be the most salient contrast in your mind?
Okay, so I think the big one you see is between metrics and logs. Then the other one is between metrics and logs / profiling, and then all of those in black box. So I'll start with just talking about logs, such as if you're using the Elk stack or Fluentd or one of those solutions. So logs and metrics are looking at the same data, but looking at it in a different way. So if you have a log line being produced per user request, for example, then you'll have so many fields in that log entry. But you're practically speaking going to be limited to maybe 50 or 100 just in terms of bandwidth and disk resources. So for every single request, you get, these 50 things, but you can't really go to 1,000 there just because it would use too much disk bandwidth, too much network I/O. For metrics, by contrast, they don't know about every single event because they're time compressed. So like every 10 seconds, every 20 seconds, every minute, you take a snapshot. And because it's not looking at every single request, because it's being aggregated across the time domain, then you can have 10,000 of those, no problem. But you're losing that per request information. So that's kind of where the big contrast is. And the way I would see it is that you would start off with your metric system like Prometheus and kind of drill down and figure out which subsystem is at fault. Look at, follow the latency through your microservice architecture and say, okay, it's this service. And looking at the rest of the metrics, because you've got 10,000 of them, you notice, okay, it looks like it's, the billing subsystem. And now that I know it's in the billing subsystem, and I know which request paths hit them, I jump over to the logs, see who's been talking that and getting slow queries, and figure out that, oh, it's this particular user, it's this request, and go from there. So there's this interplay then that metrics kind of narrow down what's going on, and then you can jump to logs to get more information and figure out, okay, we now know which subsystem, now which exact requests are the problem. And that's where I see the interplay there. The other one then is profiling. So profiling, I would consider anything like GDB, or if you're putting at strace, or any of the actual profiling tools, anything dtracy, where it's similar to logs and metrics, except it's doing both of them for a really short period of time because it's too expensive to do otherwise. Because if you're sampling every microsecond or 100 microseconds and pulling in every single event, that is a tremendous amount of data. And you can't turn that on all the time because it's too expensive. However, once you've narrowed down the problem, you can pull out your profiling tools, debug the problem, and go, okay, I figured it out. I'm going to turn this off now because I can't leave it on all the time.
Okay, and so one of those things that you listed there is that you want to be monitoring services rather than machines. What do you mean by that statement?
Okay, so as I mentioned the previous example there, if I have a machine that's running MySQL in the old model of monitoring machines, then I'll have a check that, the MySQL's turned on. I'll have a check that, the CPU is okay, the memory's okay. But if that's part of, say, a set of read-only replicas for MySQL, I no longer care about individual MySQL machine. I only care that there are enough MySQLs running to provide good service. So I might look, let's assume that MySQL is being used extremely simply. I just might look and say, right, what's the CPU load? Is it okay? Is the latency okay across the entire fleet? And if 2 of them are down, but all the other metrics are fine, like everyone's getting good service, good reliability, then there's no reason to alert. So it's kind of not thinking about each individual machine, but thinking about the overall service and the overall view that the end user is getting. So it's kind of like the pets versus cattle view.
Great. So let's start to talk about Prometheus in practice. What's a Prometheus client?
So there are the Prometheus client libraries. There's in 11 languages, I think. And the thing is, in order to get the most benefit out of a metric system, just like a log system, you need to instrument your code. And what we provide for these are the client libraries. So in Go, Python, Java, Ruby are the main ones. And you go into your code and say, right, every time I pass this line of code, increment this thing by 1. Or every time that I go into this function, time how long it takes and tracks that. Then that's all kept in memory, in a memory state. and every now and then Prometheus comes and takes a snapshot of that. So at its core, it's just the way how you say, hey, this is the interesting information that I would like to expose, and we take care of all the bookkeeping, concurrency, efficiency, and all that sort of thing for you.
So with the example of maybe the ads platform that you worked on, what kinds of calls would a Prometheus client need to implement? What methods would it need to implement? What would it need to be able to respond to? And what kinds of information would a Prometheus client need to produce? So
the client itself is very generic. So we've got 4 types: the counter, the gauge, the summary, and the histogram. So a gauge might be in-progress requests, because that goes up and down like a gauge in your car. So if that obviously goes very high, you have a problem, or maybe you've got a queue. How big is the queue versus the limit of the queue? You then got counters, like counting how many requests are coming in, how many requests are coming in for different ad formats, like say Flash versus text. And then the summaries and histograms are for timing latency, or maybe the number of bytes per request, to track that over time and see what that distribution is. So that's at the library level, what the sort of mapping you'd have for the types to what's provided. But at the end of the day, it's up to the user to build things on top of that, because the library doesn't know anything about ads, for example.
Right. And what would be the process for setting up that client? What kinds of programming hooks do you have to write to set up those different metrics that you want to give off?
Okay, so normally what you would do, so if I take the example of the Python client, you'd install it via pip install Prometheus _ client, isn't it? Yeah. And then you import it as you would any bit of Python. You create your metric. So you'd go my metric equals summary, give it a name, give it a help string. And then let's say you want to time a function. You just decorate it. So at mymetric.time, and that's it. So there's only really 2 lines of code there. One to set up the metric and then one to use it.
Great. And then what is a Prometheus server?
So the Prometheus server is the core part of Prometheus. It is what goes and talks to all the clients and all the exporters, pulls in all the data, stores it on local disk, preferably SSD, runs rules on it for alerting, and sends out alerts. And then it's also available for graphing requests or pulling out the data over HTTP, which is how almost all the dashboarding solutions work.
Do you need a Prometheus server for each of the different services that you want to monitor?
You could have one Prometheus server. There's nothing stopping you from doing that. Prometheus is actually surprisingly efficient. A single one can take like 800,000 samples per second. But normally what happens is that for organizational reasons, each team would get their own Prometheus. But there's nothing stopping you running everything inside one.
What are those organizational reasons for having one Prometheus server per team?
Per team? Well, if 2 teams are fighting over which way it should be done and have different opinions, you can do that. Or, they're different resources and they're, managing it, arguing who's going to do which. They might have their own Prometheus server. There's also an aspect of isolation there. If one team happens to put out a metric that's way too big and starts causing problems, it's going to affect everyone else on that Prometheus server. So just being able to say, look, each of you have your own is one way of looking at that. And Prometheus itself is also extremely easy to run. It's a standard Unix daemon.
You mentioned that different Prometheus clients might implement their metrics in different ways. Are there also subjective decisions to setting up the Prometheus server?
Yes, there's lots of subjective decisions. The main one comes up around service discovery and what we call relabeling. So if you look at any 2 organizations and how they think about their machines, maybe one's in Amazon and one's in bare metal. So the one in Amazon cares about availability zones and regions. The one in bare metal only thinks about data centers. So they do have 2 very different models of the world. And then the way that they'll think about the targets and the key value pairs they will associate with them is going to be different. And the interesting thing is that it turns out not only is this vastly different between companies, to the extent that no 2 of them are likely to have the same mental model, it's also very commonly different between teams and even within a team in a company, just because different people have different ideas of production versus development versus canary versus, people are laying stuff out by customer, or maybe they're laying it out by team. Just that sort of subjectivity comes in to how you lay things out. because one of the advantages of Prometheus is that everyone running their own Prometheus server can do their own thing and model the world in a way that makes sense to them.
How does a Prometheus server discover the clients that it wants to connect to?
So for service discovery, there's a few options. We'd like support EC2, Azure, Google Compute Engine, I think, is still in code review. So we can just discover machines via those. Then you have Marathon and Kubernetes, that we can pull data from there, including all the metadata they can give us. And then you've got a few things, just nerves and server sets on top of Zookeeper. There's also a console as well for people to use it. So those are more generic, things explicitly designed for service discovery. So those are all there. We can go out, fetch those, and then the user can model data however they like on top of that using relabeling.
Once the service discovery process has taken place, what is the communication pattern between the Prometheus server and the Prometheus client?
Right. So the Prometheus server will send out a HTTP request. It might be HTTPS, and it'll say, send me a scrape, normally to /metrics endpoint. And the Prometheus client will then send back the metrics. And I believe then it'll just keep that HTTP connection open and keep on sending normal HTTP requests at a regular interval.
What is a typical interval?
It depends. The default is 15 seconds. We've got people going from sub-second up to several minutes.
What might be the determination for how long you would want to wait before pinging your Prometheus client?
Well, it boils down at the end of the day to resources. Because you can imagine, if you consider 1 second versus 60 seconds, that's 60 times resources you have to spend in terms of network, CPU, disk, and so on. And you have to balance those costs. Because at the end of the day, this is a real-time streaming processing system, and those have costs.
So the Prometheus server gets set up, you've got a client running, but the client is usually an instance of a replicated service. So let's disambiguate that. How does the communication between the server and all of the different instances of a given client, how does that work? Like, am I doing a round-robin pinging of the different clients, or am I pinging them all at the same time? How exactly does that work?
So it's independent completely. So service discovery produces a whole pile of targets, and let's say we're working on a 10-second interval. Then the identity of that target is hashed, so we spread the load around, and then it just scrapes based on that. So one might be at 1 second, one might be 7 seconds if you're at 2, and they're just at an offset continuously.
Okay.
And if you had many, many hosts, it'll just happen more and more often, and the space in those 10 seconds will be more filled with scrapes. But each is a go routine, and they're independent, just with a hash for consistency.
How does the data from the different instances get aggregated?
So, by default, Prometheus will just take in the data. And there's basically 2 ways to do the aggregation. So one is when you send your request from, say, Grafana for graphing, you have an aggregator in there like sum that will on the fly do the math. The other option, because if you get to start touching a few thousand time series, that can start to get a little expensive, is Prometheus can run rules, we call recording rules. Other systems call them standing rules or standing queries, that it can just evaluate regularly and pre-aggregate that stuff. So that's cheaper to access, because then you only have to touch one time series rather than thousands.
So is the data being pushed from each client, or it sounds like this central server is pulling data from the clients?
Yes, Prometheus is a pull-based system, so it's just pulling every 10 seconds, say.
Why is there such a debate around the pull-based versus push-based monitoring?
I'm not really sure. I have some ideas why. It is a bit of a religious issue, a bit of a Vim versus Emacs. In my own opinion, there's not too much difference at a technical level between them. I think pull is slightly better, but only very slightly. One of the things that I think may impact it is that Nagios is a pull system, which can be tricky to scale, and people are thinking, oh, Nagios is pull and Nagios doesn't scale, therefore pull doesn't scale, which is an elemental fallacy. Whereas in reality, push and pull will both scale pretty well. So that's one thing that might come into it. Another one is a lot of the SaaS vendors pretty much have to use push for network reasons. So people are in for that. But I really don't understand a lot of the really vehement opinions that push or pull can't scale, because it is possible to scale both. Just as long as you're willing to spend the time.
Can you talk a little bit about how the scalability of a push-based system contrasts with that of a pull-based system?
Sure. So for a push-based system, you are going to get a stream of samples that are normally going to hit some form of load balancer. You then need to have something which is going to take in those samples, shard them back out so you can hash them across a set of servers, and then process them from there. So the load balancer there is normally where things might be a little more challenging because you have what might be a tremendous volume of data all hitting one place. On a pull-based system, you don't need that load balancer because each particular Prometheus server or other pull system is already pre-sharded, shall we say. So you might have one for the MySQL, say, and it just pulls in that data. So you don't have a large edifice of having to manage all that data.
Talking more about Prometheus, when we get data from a Prometheus client into the Prometheus server, how does that data look? What is the data format?
Well, there's two data formats. The ones that most users would see and which all the clients produce is in text. So there's a few comments for metadata, and then we might be my metric 3 or my metric 1.5. And it can also be labels in curly braces inside there. The other format, which is equivalent, is protocol buffers. At the moment, only the Go client produces that. And in fact, the Prometheus server and client use content negotiation to figure out which one to use. But the format that most people would end up using is a simple text-based format. And you can produce it, assuming you don't need the escaping, pretty easily.
The volume of data from monitoring is quite voluminous. Where does the data get stored? Does it get stored directly on the Prometheus server, or does the server push it to some other database?
So the data ends up stored on the Prometheus server. We recommend SSD for performance reasons. And in fact, with the new var bit encoding, it's only 1.3 bytes per sample in production use cases. And it sits there. But we see Prometheus isn't itself intended as a long-term data store, because the problem with a really long-term data store is that implies a distributed storage system. And that means a distributed system, and those are really, really hard to get right. And it's not my opinion that you want that sort of hard distributed system problem, which is as likely to lock up in an emergency as help you, on tightly coupled to the Prometheus server. So the idea is that we will have long-term storage of some form that Prometheus will push the data out. Like today, it can push out to Influx, Graphite, and OpenTSDB, but there's still experimental support. Ultimately, we want to be able to plug out to other systems that can store the data long term, and Prometheus can also transparently request data back from them. And then we have that decoupling where Prometheus will have maybe a few weeks or months of data right there. So even if the long term storage is having a little bit of a problem, you can still get your critical monitoring in an emergency.
So is that to say that the data on the Prometheus server since it's not replicated, it's somewhat vulnerable to being lost?
Yes, that's correct. We generally consider Prometheus data to be ephemeral. It's a cache more than anything else.
Okay.
But in terms of reliability, if you want to do high availability and have not be reliant on a single machine, with Prometheus it's really easy with a pull model. You just turn up a second Prometheus server that's acting identically to the first one, and then they both have the data, and they're both alerting.
Right, but I guess that replication model would still potentially be vulnerable to diffs between the two. But again, I guess that's since it's monitoring, you're not too concerned if there's slight difference in one instance of a metric.
Well, yeah, the thing is that there are so many race conditions in monitoring that this one doesn't actually matter.
Right.
Because if you can imagine the scrape, or even you have the exact same in a push-based system, if the network's slightly slower or faster, or the scheduler in the kernel is slightly off, you'll get slightly different results. And most of the races are of that magnitude, and you'll be looking at the similar for this. And as well, if you think about it, you don't know, once going back to the example of the 10-second scrape interval, you don't know where it is in that 10 seconds. If you get different answers and it's significant to you in terms of alerting exactly where you land in that 10 seconds, then your monitoring isn't going to be very resilient or robust. So you just need to be able to resilient to that anyway, because that's just the nature of monitoring.
So one thing I'm hearing here is that the monitoring data doesn't need to be as durable as business data. And this is, seems like a pretty fundamental difference between how we look at business data versus how we look at monitoring data. Are there any other ways in which that implication affects the architecture of Prometheus?
Well, I wouldn't say so much. There's not so much durability as the engineering trade-offs, because Prometheus, we value availability over consistency. Because at the end of the day, if your network's falling apart, you don't want something like Zookeeper that's also going to fall apart to depend on it. In terms of other places for reliability, so for example, between Prometheus and the Alert Manager. So the Alert Manager takes in all the alerts, because all of the alerting logic's inside Prometheus. It generates alerts and they go to the Alert Manager. The Alert Manager then talks to email, talks to PagerDuty, talks to Slack, talks to HipChat, can talk out JSON and HTTP if you wanted to. And our approach for making that communication reliable is that Prometheus server is just continuously repeating those messages. And similarly on the Alert Manager side, there is a repeat interval, plus a few retries, such that even because humans sometimes drop pages and ignore them by accident or sleeping in or whatnot, so there's a repeat interval to just say, hey, after like an hour, just resend that alert because nothing's happening here. So there's just multiple retries all through the system just to keep things nice and reliable. But in practice, because of, let's say that machine crashes or whatnot, you might be missing your alert for a minute, but you'll get it a minute later, and that's okay because it takes a human 5 minutes to get to their laptop anyway.
Mm-hmm. So one thing you mentioned there is that one reason for avoiding Zookeeper, and a system like Zookeeper or Console, they're often useful for coordinating a distributed system by providing consensus. What are the downsides of requiring consensus coordination, and why can you avoid consensus when using Prometheus?
Okay, so consensus is great when you need the consistency. Like you can imagine for billing data is probably the best example where you need everything to be perfect. It's just in monitoring, for Prometheus, we've made the engineering choice not to use consensus, not to use at least highly consistent consensus. Because the problem is if you have a quorum, for example, let's say your standard example, you need 3 nodes for quorum, and you have a network partition that knocks out one of them, and a machine failure knocks out the other, suddenly you can't progress. And if you, depending on exactly how you were set up, you could just then be dead in your water and the monitoring system no longer works. Whereas Prometheus just sidesteps all those questions by having each server completely isolated and doing its own thing.
Is the consensus that would be required in something like a billing system, if we were doing billing system instead of monitoring, would it be the point of consensus around the information that is being stored? Or I guess you basically would need multiple records, whereas in this case you just have a single monitoring server. You have a single Prometheus server that is the monitoring source that you're looking at as the monitoring source of truth, and you don't have strong guarantees about the consistency of that data.
Yeah, well, if you're really caring about reliability, we're running 2 Prometheus servers, which might have slightly different data.
Right.
But they will provide you with reliable alerting because there's 2 of them.
Right. So let's talk a little bit about the querying model. What is the API for querying the Prometheus server?
Yep. So the primary one is just a HTTP API that you just send it a query, and it will send you back the results. And that's how basically all the graphing solutions work. So as you just say, at this time, execute this query, or between these time intervals at this at every 10 seconds, give me the results.
So what would be an example query that we might make against our monitoring data?
Okay, so a simple one is you have a request counter. Let's just say it's called requests_total, which is a little ambiguous. So the first thing you'd want to do is convert that into a rate, so a per second value, because a counter that's just continued going up, up and to the right is what you want in your graphs, but not that useful. So you would go rate requests total, open square brackets, 1 minute, close square bracket, close power n. And then that will just tell you the per second rate and you can graph that. But then that's going to be per instance, and we care about service level stats. So we want to get rid of that instance distinguishing those. So we could then do on top of that sum without instance rate of requests total over 5 minutes. And then we'd have the request rate across, that metric for the entire Prometheus server.
And what are, this is a more general monitoring question, but what does an engineer, what are the different situations where an engineer is querying the monitoring server in the day-to-day workflow? Am I only querying it to set up dashboards? Am I querying it to figure out a situation during a fire? What are the different reasons why I might query my monitoring server?
So normally you'd use it via pre-existing dashboards because, the key statistics like requests per second, errors, latency, CPU usage, memory, they're going to be in the dashboard already for you. But as you go down and debug into a problem, like you might have one per service and then a few for the major subsystems of that service, once you drill down far enough in, it's possible that there is no dashboard for what you want already, and you would just then go directly start to write queries. And anything like that where you're exploring a metrics, maybe you got the code in one hand and knowing, hey, there's this metric here that if it's being incremented, it means we're going down this code patch, which will help me debug. And there's no dashboard for it, let me write a quick query. And that sort of interplay then, it's like, oh, right, now we're on that code path. And it's like, oh, this metric, and then it's bouncing between code and ad hoc queries.
Right. So maybe an ad hoc query in the example of the advertising is, you don't have a dashboard built to look at the metrics of a individual website that's making requests for ads. But if you start to have some kind of problem associated with that website, you might want to create an ad hoc query and query all the instances of that website requesting an ad.
Yeah. I might, because there's an interplay as well, you might even have discovered this website because it's mentioned in an error message in the log. And it's just like all these different tools are complementary between your logs, your metrics, your source code, and you look at all of them when looking at an outage.
Right. So is Prometheus, am I using it as my logging, or do I notice a problematic metric with my Prometheus metrics, and then I might go into the logs on the associated server? Normally Prometheus would spot that out. So Prometheus is good for spotting mostly systemic issues, because you notice that, hey, this error ratio is now at 1% or 2%, and then you'd go notice that, okay, I've looked at all the servers. This one server is 20%, the rest have none. Now it's time to look at that server and see what's wrong. And you can drill down like that, and then you look at that server, maybe you look at logs. From the other side, it's possible, because Prometheus is good for systemic issues. If you want to catch like a one-off thing, logs are a better option. So what happens with a network partition? So when there's a network partition between the Prometheus server and the clients that it's supposed to be pulling from, and that this partition lasts for an extended period of time, does that data just get lost, or does it get? Is there some way to retrieve it?
So in that case, the data would just be lost. Because the scrape, it will happen. Prometheus will attempt to scrape, it'll time out, it'll report the up variable as 0, and that's it. The question then is, like, particularly when you have a HA setup, and one is on one side of the partition, one is on the other, could they like resync and merge back in? And the problem with that is just first the question of semantics, because that's basically a Byzantine scenario, and you don't know which is the truth. The second problem is you just had an outage or in the middle of an ongoing network flakiness, and you're just chugging along your normal pace. If you're going to start backfilling data, you might be doubling your load or tripling your load, which might make any outage worse. So you've kind of got those two problems there that, does the semantics, it's not clear what the right semantics are, and this could actually make an outage worse. And it's that sort of situation where, by and large, it's not worth risking the reliability of the system in terms of that outage load and in terms of the code and all the risks there, than just saying, we're going to have a blip once a quarter when a rack switch, when someone brushes against it, and that's okay. And making that sort of engineering trade-off and realizing that, simpler is better.
Are there certain high sensitivity services where that's not an acceptable strategy?
There probably are, but in that case, you're looking for a different sort of monitoring.
I see.
Because at that point, you're looking for consistency over everything else, and in that sort of situation, you would turn off the service if the monitoring broke, which just because it would be bad for you to continue accepting queries because you can't reliably persist them.
So if I had an architecture that had some high sensitivity service where I need really consistent monitoring, how would I fit in that heterogeneity with a platform that is mostly fine with using Prometheus? Like, how is Prometheus compatible with that kind of monitoring heterogeneity?
It probably depends on the exact circumstances you're looking at, because with Prometheus, if the choice is between consistency and availability, we'll always choose availability because we're okay with a small blip in data. If you're not okay with a small blip in data, well, we can monitor the system that's doing that and tell you how it's generally performing with all the metrics. But for that exact precision, you'll need some other solution. So, for example, human health data. It will be a bad idea to put that in Prometheus. However, there are companies who are monitoring the systems that are doing that, and that's okay.
Can Prometheus monitor its own health?
Oh, yes, it's pretty normal to have Prometheus scraping itself.
So what's the architecture to look like for that? Do you have a separate server that is set up to be the Prometheus server?
Yeah, that would generally be a good idea. It's normal also to have each Prometheus scraping itself.
Okay, interesting. So what's the onboarding process like for a company that wants to use Prometheus?
Well, normally it's best to start at small and low risk. So you take the node exporter, which is nothing to do with Node.js, it's their machine agent. You would install that on some machines and install Prometheus to monitor those. And then you'll get 500-600 stats from the Linux kernel, like your file systems, your CPU, your network, your disks. And you can look at that, see if you like it, get used to the data model. And from there, expand out maybe to more infrastructure stuff like, say, Cassandra, MySQL, Postgres, HAProxy. And then once you're really comfortable, you can start getting the real value, which is when you start doing direct instrumentation and using those client libraries in your code. Obviously, going straight to client libraries is a big ask because it's saying, hey, I want my developers to write a whole pile of code on this system we're trying out, which is obviously a bit of a hard sell. But if you can say, hey, the node exporter, you can be up and running inside 20 minutes, and it's easy to turn off again, not a big risk, one person can do it, that's a much easier sell.
What are the kinds of services that might be more difficult to monitor with Prometheus, or might take more of a complex architecture than we've defined so far?
So ones that can be tricky is where there's lots and lots of short-lived processes. So Prometheus generally presumes that things live for a while, let's say tens of scrape intervals, whatever that is. So if things are shorter than that, you're going to miss things. So there are some things out there, I think Spark is one of them, that has lots of very short-lived things. Like even a pure serverless architecture will be tricky, although that presents its own challenges. Other than that, anything where you are trying to do what really looks more like logging than metrics is going to be challenging just because of the cardinality of the data. Because Prometheus, it's worked on metrics, and if you're creating a new time series every time you run a job, eventually that's going to run into a performance limit.
What kinds of tools do people use in conjunction with Prometheus?
So the most common one is Grafana, which is what we recommend for graphing. It's probably the biggest one. I'm not sure there's any other tools that are particularly consistent across the user base because everyone's so varied.
So your company, Robust Perception, offers Prometheus consulting. What are the typical situations that your clients are in when they come to you?
So companies big and small. So the smaller company, they mightn't have much monitoring at all and just want a hand getting things up and running. The larger companies, they tend to have an existing monitoring system. They tend to have an existing monitoring team, and they're just finding that things, they aren't scaling too well. It's a lot of operational effort. There's not a lot of value. Things aren't aligned, and it's like, how do we best use Prometheus? How do we deploy it? How do we make sure it scales? Are there any pitfalls that we can avoid? That sort of thing.
Yeah, and these companies that already have some monitoring set up, how do they integrate Prometheus into the rest of their monitoring infrastructure?
Well, typically it starts off with Prometheus, as any new monitoring system coming in, is just like a more advisory thing there on the side. And then over time it starts getting an alerting role as well. And you end up then with two monitoring systems for a while until you can cut over. But it really is a question of what your processes are and how you deal with alerts coming from a new system and dashboards in a new system. Like a lot of companies, like most of them, are already using Grafana, so it's easy for them to use the new dashboards. The challenge normally comes more around alerting and what that process is. So for example, if you're used to using something like Uchiwa with Sensu, and it's all one pane of glass there, and then Prometheus has a different one, you need to think about how you integrate those together. Like, do you write a consolidator, or do you just have two ones to look at, or maybe you have a completely different operational model?
Sure. So what aspects of an organization might change once Prometheus is running?
So one of the things is that because you can now alert on service level metrics that are related to your SLAs that you've agreed with your customers, that you can turn off a lot of alerts from waking people up in the middle of the night that aren't directly related to that. So that means you don't need to have humans in a room looking at monitors and being ready to declare an emergency. You can scale that back and reinvest that effort instead into general engineering.
Interesting. How does the workflow of an on-call person or maybe an SRE change with Prometheus?
I don't think the workflow would change too much. It might have links to more useful dashboards because it's got a richer set of metrics depending on what system you're looking at. But I think the process is mostly the same because once you're on call, it's incident management.
Okay. Do you have any knowledge for to what degree Prometheus is a rewrite of Borgmon, and in what ways is it different from Borgmon?
Well, public details around Borgmon, there aren't too many of them. There's a bit in the S3 book and some on Monitorama presentations, so I'm not going to speculate too much.
Okay, fair enough. What's in the future for the Prometheus project?
So the main things we're kind of looking at the moment, there's the long-term storage as mentioned. We want to get that in there because it's a big user request. We're also looking at making the alert manager highly available because right now it's technically a single point of failure. So we're looking at an eventually consistent approach for that so that it will continue to work in our partition. So those are kind of the two big things. And then there's just generally continuous improvement of improved client libraries, more exporters, more features in Prometheus and so on. But those are the big two things.
Can you talk a little bit more about the alerting system? We didn't discuss alerts very much. Alerting is closely correlated or closely related to monitoring. Maybe you could talk about alerting and what the unique requirements of a alerting system around Prometheus are.
Yeah. So in Prometheus, labels are one of the key aspects, and labels propagate all the way through. So you can route alerts based on labels. So normally the idea would be that you would have an alert manager per company, or a cluster of alert managers per company, and with one shared global configuration, which means that different Prometheus servers can send alerts to other teams. You can imagine if I am, say, the infrastructure Cassandra service, I can say, hey, you're running out of quota, or whatever like that. And then you basically have a tree that's walked, and different people can say, okay, this is the MySQL service. They like to go to Slack and PagerDuty. Oh, and this over here is the Cassandra service. Actually, they're using HipChat and they're using OpsGenie. And you can route like that. The other big thing is that we have grouping. So a single alert comes in, it results in one notification to PagerDuty. But you could also have it that you could say that if there's, for example, the machine down alert, because you still need someone to go fix that, that you can have that come as a single notification even if 100 machines die. So that's a massively reduced number of notifications. So you can imagine your pager then isn't jumping around on the table for 5 minutes as it's processing those, but instead you get a single notification saying, hey, there's 100 machines. And that means that you're not less likely to be overloaded in an emergency, and a better idea is what's going on. Better idea to see what's going on. The other advantage is you can do this anyway. So you can imagine something like machines you probably want to aggregate per data center. But let's say you had some system that was replicating data globally, and you had the data is stale alert. You could aggregate that by alert name, because the chances are, like if the upstream data provider is having a problem, that all the data centers are going to alert at the same time. So you can consolidate that down to one notification, and getting closer to the idea of one notification per root cause, which is kind of nice. The other thing the Alert Manager has that's you kind of need is silences. So in advance of a maintenance, you can just put in some labels and say, hey, if it matches these, don't alert for the next 2 hours. So that's really useful as you expand out. Some more interesting aspects of the Alert Manager is just performance, because when you have labels and metrics, it's easy to create many alerts. So you need to make sure that's pretty highly performant. So you could easily have tens of thousands of alerts active at a single time.
Great. Okay. Well, Brian, I think this is a reasonable place to stop. Where can people find out more about you and your work?
Sure. Well, the main place to look at would be the Robust Perception website, in particular the blog there. So I write a post usually on Prometheus once a week. And as well for Prometheus generally, Prometheus.io has everything.
What kinds of things have you written about recently?
I looked a bit more about why we don't have one agent per machine, but rather an exporter per thing. I've looked at monitoring per consensus. I've looked into how counters worked. It's written so many posts at this point, it's hard to keep them all in line.
Well, that's great. Okay, cool. That's a good reason for people to go check out your blog. Well, Brian, I want to thank you for coming on the show and talking about Prometheus in detail. I really appreciate it.
Thank you.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.